Today we're going to start off with some trigonometry antiderivatives, and to begin we're just going to need to remind ourselves of the 6 rules we began with when we first did derivatives for trig functions. Now these are presented backwards because we're doing the antiderivative form, but we want to remind ourselves here. So hopefully we're comfortable with the idea that the antiderivative of cosine is sine of x. And hopefully we'll remember to add our plus c there, that constant of integration, that constant that we don't know. The antiderivative of sine of x is cosine, but remember that when working with cosine, the derivative is negative. So that's going to be the case here with the antiderivative as well. Sine becomes negative cos. Secant squared is tan x plus c. The antiderivative of cosecant times cotangent is negative cosecant x plus c. The antiderivative of secant tan is secant x plus c. And cosecant squared is negative cotan x plus c. Quick reminder about the negatives. You can remember which ones have negative signs by remembering or noticing which ones have answers that start with C. Let's solve a few problems. I'm going to do 3, each one a little bit different. You can pause the video and try these problems as you want. Maybe listen to the first one, pause, try the second one. But just remember that you can start and stop as you need to try and give yourself some practice with these problems or understand trig antiderivatives. So the first one, antiderivative of secant squared x plus cosecant squared x. We've got addition here, so remember that we can split these two problems apart. Secant squared x plus the antiderivative of cosecant squared x. And we have rules for each of these. The antiderivative of secant squared x, we just reminded ourselves, is tan x. The antiderivative of cosecant squared is negative cotangent x plus c. I only wrote the plus c once. There are constant of integration. It's a random number that we don't know. So writing it twice is just redundant. So I just put it once. Moving on to our second problem. The antiderivative of 6x squared sine x cubed. If we were doing derivatives, we might think product rule, but we don't have an antiderivative product rule. So we might be inclined to think we need a u substitution. And I notice that there's this x cubed here, and that when I do the derivative of x cubed, I get x squared, something x squared, and there's an x squared on the problem. So I think that's going to be useful. I'm going to move the dx to the other side, just so it's in a form where it will be easier to recognize the substitution. And I've got 3x squared, but I want it to be 6x squared. So I'm just going to multiply both sides by 2. All right, now we're ready to rewrite our problem using substitution. So it becomes the antiderivative of sine, instead of x cubed, that's now a u, and the 6x squared dx becomes a 2dx. I'll just rearrange it so it looks a little bit more familiar. 2 sine of u du. That should have been that dx should have been substituted out and changed into a du previously. Okay, we have a rule for sine. The antiderivative of sine is negative cosine, so this answer is going to be negative 2 cosine of u plus c. I started with x's. I now have u's, so I don't want to leave this as a u, so I'll substitute back in negative 2 cosine x cubed plus c. All right, our third problem. Again, we have a product here. And I notice tan x and secant squared x. I know that if I take the derivative of one of those, I get the other one. Or vice versa, the antiderivative of one, I get the other. So we try one of these out. But I recognize that when I take the derivative of tan x, I'm going to get secant squared x. Notice that those derivative rules we're going to have to remember and keep track of them as well as we work with antiderivatives. Move the dx to the other side. and I'm ready for substitution. So the antiderivative of u to the 1/2 power, and secant squared x dx just becomes du. Now I can do this antiderivative using the power rule. Add 1 to my exponent, divide by my new exponent, plus c. Let's rewrite that without a fraction in the bottom. 2/3 u to the 3/2 plus c, and then substitute our u back in. 2/3 tan x 3/2 plus c. We could rewrite that rational exponent, but I'm just going to leave it there.